Sorry. I hope that you get better sleep this evening. That's not good for you. List A, B, H, and K. A is 4, B is 2. Is H pi over 2 or negative pi over 2? Very good. And then K is 2. Bless you. If my B value is 2, this is a cosine graph, so my period will be 2, or is it pi over B or 2 pi over B? 2 pi over B. It's yeah. So that means our period is pi. This graph, when we shift it, what directions will it go? It's going to go right, and then it's going to go up. So when we go, have you guys gotten the feel for adjusting your graphs as you start to draw them out? So I know I have to go up and right, so I'll just make it a little bit longer, a little bit more up. If I place pi here, then pi over 2 would be here. Pi over 4, and 3 pi over 4. I'll worry about my shift stuff later. My A value is 4, so I have to go up and down 4. And then I go through the process. Does cosine start at A or does it start at 0? When you get going to your ordered pairs, it usually works out rather quickly. To each of these, I have to add pi over 2 and add, 2? Yeah. Were you guys working with fractions without trying to crack your skull as you're doing the thinking there? You know, like 0 plus 1/2 is. I know it's a lot. So we get pi over 2, 6. 1/4 plus 1/2 is 3/4. Sorry, I was standing in your way. You can't see stuff. You don't care. 1/2 plus 1/2 is a whole. And that would be 5/4. And then 3 pi. So now I know that I'm going to be able to reuse a couple of my tick marks that are already there. I'll be able to reuse pi over 2, 3 pi over 4, pi, which means I have to space out 5 pi over 4 and 3 pi over 2. You all right? All right. Sounds like something scary was happening. It's just that. Where's your new 0 line? 2. Hey, what? That also happens to be the K value. It also happens to be the K value. So as we go through, we know we're at. Oh, we got to make 2 more here. So I have pi over 2, 6. 3 pi over 4, 2. Negative 2, 2, 6. Sorry. It's close-ish. Now, this is where I want you guys to see what happens. What happens here, Blair's just a little bit. What happens here is if you look at it, your K value, your 0 line, moved up to 2. So that means when I'm at my 2 ordered pairs that are at 2 act like zeros. They're shifted zeros. Are we all right with that? So from here, we go through the process of checking reciprocals. Since we just graphed the cosine, what I now do to those 5 ordered pairs is I figure out reciprocal spots. And you basically just flip everything. What happens, what is the reciprocal of 0 though? It's undefined. What occurs at undefined on graphs? Asymptotes. So these zeros then become asymptotes. Okay, the zeros become asymptotes. Then, yep, the new shifted zeros. That's why I asked where did the 0 line go to? Basically, y equals k is going to be your new 0 line for all of these. It's kind of convenient to know that. And then instead of what's the reciprocal of diving down? It's jumping up. So if this is a maximum of a cosine, it is a minimum of a secant. If this is a minimum of cosine, it is now a maximum of a secant. If this is a maximum of a cosine, it is now a minimum of a secant. And that's all you're doing. You are quite literally flipping them. You plot like you would normally and blow it up. Seriously, that's all you're doing. You blow it up. Okay? It is super easy to show you why this works. If I graph a simple sine curve on a 2 pi period. Let me show you what I mean. If you graph a simple sine curve, I'll go back to it. Sine curve. Does it start at 0 or does it start at A? 0. It goes 0, A, 0, opposite of A, 0. Sine does that, right? What's the reciprocal of 0? Undefined. What's the reciprocal of 0? What's the reciprocal of 0? Undefined. Now, on the unit circle, somewhere between 0 and pi over 2 happens to be, what would it be, pi over 6? Pi. Thank you. Happens to be pi over 6. You guys agree with me on that? What is the sine of pi over 6? It's 1/2, right? We okay with that? Sine of 30 is 1/2. So that means at pi over 6, this is 1/2. What's the reciprocal of 1/2? 2. Somewhere else in the positive value, sine is still 1/2, right? What's the reciprocal of 1/2? So your cosecant, remember, does this. Somewhere in here, sine is negative 1/2, which means you're at negative 2. That's why when you reciprocal them, they just blow up. They just go the opposite direction. It doesn't matter if it's a secant or a cosecant graph. All you have to be able to do is figure out where the zeros got replaced when they got shifted at k. The values where it crosses k then become asymptotes. Whether it is a sine graph or whether it is a cosecant graph or a secant graph. Now, when we did stuff with tangent, remember how you'd have parent functions, you'd have parent asymptotes, then you'd have shifted tangent asymptotes, and then when you flip things around with cotangent, you could have another set of asymptotes. That's why I don't graph cotangent in algebra 2, because because you'll have 6 asymptotes usually on one graph. It gets horribly messy. It's not difficult, but when we get to algebra or we get to pre-calc, there's a different way to graph some of these. I wouldn't say it's any easier. It's worded a little bit weird, but it's less parent function, more straight function. So I just didn't want to confuse you with any of that stuff today at all. Right? Meh?
No.
Well, I know your answer to everything, so I'm okay with that. If you're saying no, then I'm going to be like, all right, fine. No, I'm going to do a cosecant graph now. So let's see. Actually, let's do this. Let's make the instead of being 2x. Try to make this not as messy. Oh, that's fine. So I have -2 cosecant times the quantity 1/2 x minus pi over 4, all plus 3. Label out. Well, first of all, what should we do with that 1/2? We factor out a half. So I factor out a half. I'm going to get -2 cosecant 1/2 x minus, well, 1/2, bless you, times what is 1/8? Excuse me. 1/2 times what is 1/4? 1/2. So when you factor that out, okay with that? Whenever I factor something out, especially if it's fractional, I'm always going to say in my head real quick, all right, what's 1/2 times pi over 2? Pi over 4. That way I know that I factored out the right thing and I didn't accidentally screw something silly up. Now you got your A, B, H, and K. A is -2, B is a half, H is pi over 2, and K is 3. If my B value is 1/2, that makes my period 4 pi. It's really hard to take half of 4 pi, but I think we can do it. Big. It's going to go right and up, so again, I'll do sine graphs. Do sine graphs start at 0 or do they start at A? 0, then they go to A. Yes, sir. Yeah, what's pi? No, it's a cosecant graph. So that's your period is 2 pi over B. Tangents, remember, tangent's the only one that's only pi over B. Sine graphs, where they start at 0, they go to their A value. This case, our A value is negative, which means I have to go down, then up. You look tired. You okay? Well, I think we help. Try. It's not big to do anything. So let's see here. We have pi over 2 and 3. It's a whole bunch of little fractions. Six will be 7 pi. Yeah. 8 pi over 2 is 9 pi. Be all right with that? All right, I will wait. Then I will just ask the simple question: where is our new k value? Or no, k value is at 3, which makes our new our 0 line going to be at 3. It's not you don't have to, but just remember that your k value is going to be your new z value. Or 0 z value. I don't know. I'm thinking stats right with z tables. I apologize. So I just have to move everything over just to half. So all my new breakpoints are just halfway in between here. Those are all my new breaks. Okay. So I have pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and 9 pi over 2. If it starts to get too messy, it's not that big of a deal if you don't mark them here, because you're listing them on the ordered pairs. And that's what I'm hoping that I'll be able to see. So let's see here. We start at 3, 1, 3, 5, 3. Let's make that dot bigger. And then what do I do at all the zeros? They just become asymptotes. Zeros become asymptotes. If that's a minimum at 3 pi over 2, it is now a maximum for the cosecant. And you're done. Yeah, and that's it. The extra step here, guys, is after you figure out where your new 0 line is, anything that would have crossed the 0 line becomes an asymptote, and you just blow it up. Sir. No, no. And when you guys, if I ask you to graph a cosecant, this is what it would look like. You would list your parent function for the sine graph, and then when you've done graphing, you show new asymptotes, and you just blow it up. That's all you have to do. You don't have to list out ordered pairs. You don't have to list that those are asymptotes at those values. When it's an inverse function, that's all you have to do for me. Okay? Is that what you're getting at? What do you got? I couldn't hear you. What's that? Yep. Yep. Just leave it there. That's all you got. Just that's what you're doing. You're using that as the model. I'm fine with that. People have asked if they can use colored pencils to change colors. If you want, go for it. Cool. Whatever. And then I'll just color over it. I won't do any work. That might be tough to look at, though. The other question came in when we talked about this idea of reflection. I want to explain to you what that means. Yeah, I don't think I had the tangent one, though. But reflection thing's the same idea. Really, when you're reflecting, you're just flipping it over the axis, which means you change your A value from positive to negative or negative to positive. That's all it means. Okay? So, excuse me. No, I'm not going to do a cotangent. Like I said, I'm not going to have you guys graph cotangents. Just secants, cosecants. Cotangents, too many asymptotes. What this is asking you to do is rewrite the equation that's been shifted. So when I start thinking of this way, if they're giving me an equation, if it tells me the parent function, it's a tangent graph. I have an a value of 4, I have a b value of pi over 2, which means my period then is going to be 2. Because your period would be pi over 2, multiply the reciprocal, just get 2. Then I'll come to the translation here in a second, but a lot of times it's really quick to just kind of visualize what it looks like. You have a value of 4, that means you've got those 2 points of inflection. If your period is 2, that means half of it is on one side of the 0, the other half is on the other. Well, what's half of 2? 1. So that's why we have it here at 1 and negative 1. Okay? What's halfway between 0 and 1? Half. Negative half. So this one was positive, so is this one increasing from left to right or decreasing from left to right? Increasing. Good. So we know that the graph would look like this for the parent function. It states that this graph gets translated up 6 and right a half. And that's reflected over the line y equals 6. Well, if I'm going to move these things up 6 and to the right a half, that means I need to move all of my asymptotes first. You okay with that? So if I move my asymptotes to the right a half, I move from negative 1 a half to the right, where's the new asymptote? Negative half. If I move to the right from here, I will be at 1 1/2, or 3/2, excuse me. Okay. What's when you think about now, your new 0 spot on the x-axis is going to be at 1/2, and it's going to go up to 6. Okay. I take this point that was at 1/2 and 4, I move it over a half, and I go up 6. I'll do the same thing here. I go over a half, and I go up 6. So 1, 2, 3, 4, 5, 6. But here's where it's interesting. It says that the graph is reflected over the line y equals 6. Y equals 6, is that a horizontal or vertical line? Is it horizontal or vertical? It's horizontal. So if I have a line at y equals 6, the graph right now is doing this. If I reflect it over that, what's going to happen? Go ahead, Ben. You're right. You're right. Say it. That's all it is. It just flips. That's all it means. It means it flips. And if it flips direction, what happens to the a value? It becomes negative. That's all it means. So your new equation would be negative 4 tangent pi over 2 x, and then we had to go to the right, what? 1/2. So was that minus 1/2 or plus 1/2? Minus 1/2. And our k value? Plus 6. And do you have to put the k value at the front or the back, or does it matter? Doesn't matter. Could you have done that without graphing it? Absolutely. If you understood the terminology, by all means. Okay. And then really the only other thing that I've ever thrown on in quizzes like this is that I could give you a parent and a shift, and you'd have to just kind of figure out what the A, H, and K were. That's easy. You're just looking at ordered pairs. Okay. So other than that, it's just going to be sine, cosine, tangent, or secant and cosecant, one of the 5. Well, a mixture of those 5, and then write an equation, either like this, or I'll give you a graph and write the equation. We're talking, I think this is like 4 questions, maybe 5 at most, because when you're graphing these, it takes a minute or 2 to make sure the points, and that way it gives you time not have to worry about fractions and all that kind of junk. And I try not to make sure that you have 7/8 and a 7/1/5, or that'd be awful. I would think about it. Oh, want to see something cool? No. Wait. Next year, you get to do this too in this section. You get to do this. I don't think so. So you can graph stuff like this. No, I just want to show you something cool you'll do next year. I think that's what this looks like. It's a muted sine function. Or better yet, when you do this, a dampened sine function. Cover your eyes. You guys have no fun. Then watch what happens so they can dive into each other. Starts creating like a funneling effect. You'll graph all of this stuff. It's great. Bye, Devin. I posted some extra problems. You want to take a look at them? I'll send you the quiz for tomorrow later on today. You won't do it now, but you'll do it tomorrow. Smell you later. Watch this. It's the absolute value of the function x times the cosine of x. Watch what happens when you make it negative. It's a bat. It's Batman. It's a bat with a mohawk. What sine does. Yeah, don't worry about anything on that worksheet that says cotangent. Don't do it. There's sine. Yeah, I posted a very simple little. I posted some problems here. Don't worry about anything that says cotangent or a cotangent on it. Treat it like a regular tangent graph. On the back end of the worksheet, if you look at it online, it's got some solutions to it. Let's see, where is it? What this graph, or what CUDA does, is that they graph it in two revolutions. They do 2 full periods of graphs. I only care that you guys do 1. So if you see it like, oh my gosh, I only have 1 line, why is there 2? Don't worry about it. And the other thing is they don't put into asymptotes when they show the rough ideas. So you get a rough idea of what something's going to look like. Like I said, don't worry about cotangents. Don't worry about them at all. I'm not going to make you do it. But yeah, there's some good ones to try out. I'm really sad that Trig's over. This is the last day of Trig. You know, it's just review stuff. Okay. All right. I told you I'd be done for you. Did you have? Were you having enough time? You were leaving only like 10 minutes, right? Look, I finished just. Have a wonderful afternoon. I will do my best not to freeze. Well, I won't. I don't have baseball now. I would